So how do we find perfect roots without a calculator? Well, we need to look at the factors again. And how do the factors work for squares? We need to be able to find pairs, factor pairs, in order to see if it's the number of the square area or not. So here I have 676, and what we want to do then is we want to factor this. So 676, okay, we're going to factor this into 2 times 338. Okay, so this is going to be 2 times 169, and 169 breaks into 13 times 13. And so when we list out the prime factors of this, we have 2 times 2 times 13 times 13. We know we have squares, or a perfect square area, if we can group the factors into pairs without any leftovers. So here we know that this area of 676 meters squared must be a square area, and in fact that square area is going to be a 26 by 26 area. Okay, because we know that we can pair this up into 2 and 13 times 2 and 13. Well, there's our length and width, 26 by 26. For cubes, we have to be able to put them into 3 equal groups. So we need to again factor this. Okay, so 1, 13, 31. Okay, this is going to be, if I divide by, I think 11, I get 11 and 121. So I get 11 times 11. So here I can put these prime factors into a group of 3, which means then it is a perfect cube. So I know that 11 cubed is equal to 1331. Okay, so for cubes, we need to put into 3 equal groups. So I'll just highlight that as well. Okay, and then for perfect power 4s, we then need to put into 4 equal groups, etc. So let's take a look at some problems here. So here we have a problem. It says a certain number has exactly 8 factors including 1 in itself, and 2 of the factors are 21 and 35. So what's the number? Okay, so 8 factors mean there's 4 factor pairs including 1 in itself, and we have these 2 factors here, and we can break these down into its prime components. So 21 is equal to 3 times 7, and 35 is equal to 5 times 7. Okay, so we know that it's got to be multiples of 21 and 35, since it is 21 and 35 are its factors. So we can kind of guess at these. And if it has factors of 21 and 35, we know it involves the factors of 3, 7, 5, 7. So we're going to use the lowest common multiple so that we include all the factors. So we know that these are all included. And we want to start with the lowest number that we can test. So that in this case is going to be 105. So we take our 3 times 5 times 7. We're just going to use one of those, and we get 105. Okay. So looking at 105, we can see if this one has 8 factors. If it doesn't, then we need to go to the next multiple. So it has 1 and 105 as factors. Okay, the next factor pair would be 3 times 35. And then we would have 5 times 21. And then we'd have 7 times. So 7 times, what would 7 times be? 7 times 15 then gives us the last factor pair. So if we count them up, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, there's got 8 factors. So we know that the number is equal to 105. Okay, so we know that the hint here would be that it has factors of 21 and 35. So it must be a multiple of those. And so we start with the lowest common multiple of 105, and then we would test multiples that the next multiple would be 210, etc. to try to solve this problem. In this case here, our first guess was correct.